put the input variable. This is called function notation, f of x. It is not f times x, it is f of x. We always get some students, even at the pre-calculus level, who still have that confused. So it just means we have some, over here we're going to have an expression and it's going to have some x's in it. So you have, this thing is called the name of the function. This is the input variable. That's why this here is called input variable. And what comes out of the function machine is the output variable or expression. So for example, if I have this here and I plug in Kelly, Mr. Kelly gets plugged into the function, then what came out was Urkel. Oh man. If I had more time, I'd have put Kelly's face like in there, but it's with glasses, but that's just funny to me. Oh, Urkel, okay. So that's how function notation works. Here we go with our first example. Let's take x squared minus x plus 1. And this means that if 2 is the input variable, then you just plug a 2 into wherever there used to be an x. That's all of this is. And then you simplify, and you get f of 2 equals 3, and that is our final answer there. Pause if you need to write that down, if you don't have it yet. Next, let's take f of...
Okay, I'm going to speed ahead because he's going into things that we're either going to do later or not at all. So just be patient for a second while I get to the next thing that we're going to actually look at. We're not going to do these calculator tricks because we're going to be using the calculator that's right in Desmos. All right.
Most of the time, table ask will be good, but you might find these other ones helpful as well, depending on what you're working on. I'm going to start speeding up a bit on my notes just because we want to get through this. This is pretty easy stuff. Let's get through it. So we're now going to be looking at how you can compare ordered pairs with a table of values in a t-chart. So if you have a bunch of x's and a bunch of y's, this 3, negative 5 is exactly the same thing as just having this ordered pair. But that is something you probably already know, so we're going to go negative, ooh, that was bad. Negative 7/3 and 16. Here we get 0.8 and 0. Okay, so this is something you're familiar with. This might be one that you're not quite so good at, but basically function notation is just if the x value is a 3, then the y value is negative 5. That's function notation. It means exactly the same thing as this coordinate point. Okay, so what's funny is that sometimes I'll have students who see something like this, f of negative 7/3 equals 16, and they start freaking out. Mr. Bean, I have no idea what this is. What is going on? And so then if you just rewrite it like an ordered pair, I'm like, that's all it is. It's just an x and a y. Okay, pretty simple. 0.8 is the x, then the y value was a 0.
That means, guys, that the input was 3, the output was negative 5. If I had an equation, I'd plug in 3, I'd get out negative 5. If I was looking on a graph, when x is 3, y would be negative 5. Okay, so this x-y relationship, and again, the output depends on what you put in, so we'll see that more as we go forward.
That's function notation. And you have this phrase, depends on. It's exactly the same thing as saying, is a function of.